Hi, I'm Sri Charan. This is Digital Signal Processing LAB01. Today we are going to study the performance of three different types of filters, that is moving average filter, derivative filter, two types of derivative filters, first order difference filter and 3-point central difference filter. And then we are going to answer the four questions, following four questions. Moving average filter. Moving average filter is a simple low pass filter commonly used for regulating an array of sample data or signal. It takes m samples of input at a time and takes the average of those to produce a single output point. In equation form, this is written as y of I equals to 1 by m into sigma j equals to 0 to m minus 1 into m minus 1 x of I plus j. Due to computation or calculations involved, the filter introduces a definite amount of delay. Implementation of moving average filter. Uh, as we can see in the figure, this is the implementation of 5-point moving average filter. Since it is a dynamic system, we have to store the past input values. Here we are going to average the past 5 values and we are going to assign it to a one output point. Um, there will be a delay between samples we take, and once we get the m points, we will arrange them, average them, and assign to the first sample. That is, uh, if we have to take the first 5 values average x of 1 plus x of 2 plus x of 3 plus x of 4 x of 5, then it is equals to the y of 1 first output point, and we average them, that is x of 1 plus x of 2 plus x of 3 plus x of 4 plus x of 5 by 5. We'll get the single output point. This is the implementation of moving average filter, 5-point moving average filter. This is a code, Arduino code to implement moving average filter. Here we are going to initialize y of output, which is y. For it is initialized, it is declared uh, y array with length of 1000 indices. So we are going to declare all the indices in y array to 0 here. In void loop, we are going to write the logic. Here we are initializing sum equals to 0. This loop is iterated for 1000 times. Here k value is 1000. Since input values are 1000, we have to read the input values into x. Okay. Now we are going to add the past L values and average them. So j less than L, j equals to 0, from 0 to L values. We are going to add them, and once we add them, we are going to average them. That is sum by L, number of L. L means number of L values. So next we are going to print the values. This is the to print in a figure, like plotting. This is the output of moving average filter. This blue colored signal is the input signal x of I, and this is the output of moving average filter. uh, as we can see, the difference between input and output, we have filtered out the high frequency noise. Hmm. So as said, moving average filter is the low pass filter, and this is first order difference filter. It is the difference between present input and the past input. In the equation for y of n equals to x of n minus x of n minus 1. This equation and this filter preserves the edges and is used to detect edges. It is a high pass filter, and if we apply transform to the equation, we'll get this h of z equals to z minus 1 by z. From the z transform, we can tell that the filter has 0 at z equals to 1 and pole at z equals to 0. This is a simple logic. We are going to read the values into X array, and we have to declare the y array, and in the logic we have to subtract present input and past input, and we have to assign the output to the y array y, and we have to repeat this for 1000 values. Since x length of x is 1000, the output of the code is this. The signal is the input signal, this is the output signal. And as you can see, the input difference between input and output, mm, the output signal is a high frequency signal. This so as said before, first order difference filter is a high frequency, it is a high pass filter. So from the input signal, it filtered the high frequency noise. So we got this output high frequency signal. 3-point central difference. If it is the difference between present sample and the past third sample from the current one. That is, if we take the present sample is x of 4, we have to take the past third sample. That is, x of 4 is the first one, x of 3 is the second, x of 2 is the third. So 3-point central difference, that is 3-point central difference. If we apply Z transform, h of z equals to z square minus 1 by z square. Mm, as we can see from the equation, z square uh, terms, so they this filter has poles at z equals to 0 and 0 at z equals to plus 1 and minus 1. This is the simple code. The difference between first order filter and 3-point filter difference is, here we have to subtract from third sample. So x of I minus x of I minus 2. This logic is repeated for 1000 values because input is 1000. The output of the code is as follows. This is the input signal and this is the output signal. As you can see, the difference between input and output, the output is high frequency signal. Since this filter is also a high pass filter. Baseline drift component extraction. From the signal, this is the input signal. This input signal consists of uh, PPG and baseline drift signal and high frequency noise. This PPG is pure PPG. Now we have to extract the pure PPG. So now what we are going to do is, we have to pass the given PPG through low pass filter. Then we will get the output as PPG and baseline drift. Now we have to pass this X1 signal as through moving average filter with M equals to 400. Now we will get the baseline drift component. Uh, so now we have extracted the baseline drift component. Now we have to subtract the X1 signal, that is PPG plus baseline drift with baseline drift. Then we will get the pure PPG signal. The code is as follows. Here we are calculating. This is Here we are passing the input signal through moving average filter. This is the logic for moving average filter. Y of I is the moving average filter output, and that means x1 PPG plus baseline drift component, and we are passing the input signal through moving average filter with L equals to 400. Then we will get the output baseline drift component. V of I is the baseline drift component. Now we have to subtract the Y of I and V of I. We will get the W of I, which is a pure PPG signal. The output of this code is as follows. This is the input signal, this is the output of moving average filter, and this is baseline drift component. We have to subtract the moving average filter's output and baseline drift component. We'll get this output. This is the pure PPG signal. And last question, find the output of signal processing system which performs derivative filter and then perform moving average filter with n equals to 8. Now we have to pass the input signal through derivative filter. Second derivative filter means first order derivative filter, and then perform moving average filter with n equals to 8. So now we are passing the input. This is the input signal. We have to pass it this signal through first order derivative filter. This is the output of first order derivative filter, and this output should be passed through moving average filter with n equals to 8. This is the output of that signal, that filter. The code for this question is this. Now we are calculating the difference. That is, we are finding out the output. This is the output of first order difference filter. X is the input, and we are finding the difference, and P of I is the output of first order difference filter. Now we have to pass the first output of first order difference filter through moving average filter with L equals to 8. This is the code for that part, and this is the output. Thank you.